Good morning, ladies and gentlemen. Welcome back. So this lesson is on linear quadratic systems. We're taking a look at the worksheet. And a lot of you actually understand this from grade 10. For grade 10, we talked about lines, straight lines that intersect once, never intersect that. It's actually parallel lines, or they intersect everywhere, which means coincidental, right? They intersect everywhere. So in our lesson here, a linear quadratic, a straight line and a parabola, we actually can solve them algebraically. What does that really mean? Well, a lot of you remember these techniques from grade 10, namely substitution and elimination. I actually taught this to my grade 9 and grade 9 and comparison. It was the third technique. But by and large, most of you know these two techniques for the Sissian lines, right? As a recap really quickly over here, I'll show you visually. That's the one solution. That's no solution. That's the infinite. That's again in grade 10, right? You guys remember doing that? Mm-hmm. Sort of. You also did word problems. Hey, don't mean to scare you, but that's what you did, right? The distance time problems. You did the, break-even questions. You did the number questions. All good stuff, right? However, with linear quadratic systems, there can actually be 0, 1, or 2 intersections, right? Notice again in the linear one, straight lines, they can only intersect once, right? That's it. And they go their merry way. So a lot of you are going to understand this in a moment, that we're going to be doing the question from example 1 from your handout, where we have example 1, x squared plus y squared equals 25. This is the nonlinear part. I think everyone agrees. In fact, a lot of you recognize this is a circle, because it's actually drawn on your graph. And this is the linear component, y equals x minus 1. So technically, we can do it graphically or algebraically. I'm going to cheat a little bit. If you want to know more about the graph, I will give you the answer graphically as a sketch, because I don't have it. It is on the PowerPoint, but I'm actually going to walk through the algebraic method for this before we continue. Any questions from the class? So we want to know, does this circle and does this line, does it have no intersections, a 1 intersection, or 2 intersections? So let's just show you how we're going to solve it. So, right over here, let's just erase this. I'll do it over here. Probably just a little bit over. Sorry, Maria. So a lot of you realize that this is probably the first equation. Oops, did I go off screen? First equation, that's the second equation. And I think a lot of you know, we're probably not going to use elimination. Let me explain why not elimination. Because the second equation, it has a degree of 1, and this is a degree of 2, so we can't really eliminate. It's almost impossible. So you have to kind of rely on this technique of substitution, usually. Okay, so this is actually what I'm trying to emphasize. So a lot of you know what I'm going to do. I tend to like writing out the instructions to the reader, which is you, or if I was a teacher, you would communicate your stuff. So we're going to do sub equation 2 into 1. Hopefully you can follow along, or you can try it yourself, ladies and gentlemen, but I think you know what I'm going to do. We're going to get x squared plus x minus 1 squared equals 25. And some of you are slowly kind of recalling, hey, we've kind of done this already, right? Not at this question, we've kind of done this replacement, right, with our max-min word problems or our root word problems, right? We've kind of done this already, right? So, but we have one variable, and now we can actually solve this. Any volunteer have an idea what we should do next? Just tell me, I'll do the math. But what should we do? Solve it.
Expand?
Sure, we should expand this one. And if we expand this, we're going to get x squared plus x squared minus 2x plus 1 equals 25. And just to speed it up, we'll get 2x squared minus 2x minus 24 equals 0. Let's just pause here to notice this looks like a quadratic that we can factor out a GCF or divide everything by 2. So what are we going to get? We're going to get x squared minus x minus 12 equals 0. But if you remember a couple of classes ago, in order to solve, anyone have a strategy? Should we use, radicals? Should we use the quadratic formula? Should we use factor? Any volunteer? Plural.
Factor.
Probably factor. This is actually very easily factorable. Any volunteer want to factor this? Miriam?
X minus 4, x plus 3.
Let's just pause here for a second. She's done it really well, nicely done. If you're not too sure how she got it, you can always double check by expanding to get the above line. Right? Here's what it's weird, right? Notice I'm trying to leave the instructions here because some students, for some reason, they will just stop here. They'll say the solutions are 4 and negative 3. But one more time, we're trying to find the solutions for this. And clearly, this straight line will cross at 2 points. Again, a point has an x component and a y component. So I think a lot of you know what I'm going to do next. With this x equals 4, the equation that's easiest to probably plug this in is equation 2. It should be also okay if you plug in equation 1, but equation 2 is easy because it's the linear component. Not always are you going to do this, but I think a lot of you know. We're going to sub x equals 4 into 2, and we're going to get x equals 4 minus 1, no pressure. That's not x, that's y. Y equals 4 minus 1, y is equal to 3. Similarly, for the other in x value, we're going to sub x equals negative 3 into 2, and we're going to get y equals negative 3 minus 1, which equals negative 4. In summary, I think you guys understand what I'm going to do. The first solution is 4, 3, and the other solution is negative 3, negative 4. And notice this straight line, and I'll try to draw for you as best I can. Looks something like that. And I apologize, it looks something like this. This is this line. And those 2 points. Does that make sense, ladies and gentlemen? And clearly, that's our first example. Can we check our answer? Can we check our answer? How can we check it? Any volunteer? How can we check this answer? So,
You could input it into 1.
yeah, equation 1. So we square 4, that's 16. Square 3, 9. 16 plus 9, 25. How about negative 3 squared? Negative 3 squared is 9. How about negative 4 squared? That's 16. These are the 2 solutions. Laura.
But I have a question regarding, because like for factoring one, what we found is the x-intercepts. But then
I know, so that's why this is not really a parabola. It's a quadratic, you're correct, but that's why I'm trying not to get you confused. We're trying to solve the solution for this. Right? So this is not a quadratic at all, right? It's just giving us the 2 possible answers for that intersection. Is that okay? Let's try example 2 though together. Let's try to do example 2. This time we'll get someone to help us out. Can I erase the chalkboard though? Anyone still need this answer? Number 2 solution. Example 2. On your sheet, and again, if you need more room, please feel free to use your notes. Find the points of intersection of a line and a parabola. So this is clearly a more traditional question, what you're probably faced with. The one that we just did as example 1, we're just trying to show you nonlinear relationships. So we have a parabola. So y minus 4 is equal to negative x plus 1 squared. And for question A, the straight line is y equals negative 4x plus 4. So any volunteer from the class? Maybe want to start us off? What do you think we should do first to solve or to find the points of intersection? So, do you have an idea?
Rearrange the quadratic equation first.
Sure, how would you like to rearrange it?
Just add 4 to.
Sure, so we get y is equal to negative x plus 1 squared plus 4. Sure. Anyone else like to give us now the procedure? That's good, I would do that for sure. Where at?
You'd sub 2 and 1.
Sure, let's flip numbers. So that's equation 2, that's equation 1. So sub 2 into 1, so I think, and again, try to see if you can do it yourself, but I think you understand we're going to replace the y with this negative 4x plus 4, and that's why we call it substitution. Before we continue, everyone okay? There's a couple ways of doing this, right? I think everyone agrees if there's a plus 4 and a plus 4 on both sides, we can get rid of them, right? So we get negative 4x is equal to negative x plus 1 squared. We can also get rid of the negatives, right? Or, yeah, get rid of the negatives, because they divide out, because on both sides. Here's where you can decide how you want to shine. What do you think we should do next? Did I go too fast, by the way? Because I'm just running out of room. I just want to make it look nice for the video. We're hitting them, right?
Do you expand the bracket?
Sure, let's expand the bracket. Can everyone actually expand this perfect square? Really easy. Where you go?
X squared plus 2x plus 1.
Nice. For some reason, some students still make that error. 1 times 1 that they think is 2. That is incorrect. All right. So subtract 4x to both sides. So 0 is equal to x squared plus, not plus, minus 2x, 1. And here's where we think we're stuck. Any volunteer of an idea? Flora?
X minus 1 squared.
0 is equal to x minus 1 all squared is correct. So, I know this seems weird. If you need to put this out as two binomials, x minus 1 times x minus 1, we're not finished yet, I'll move it over here. Can someone tell me what is x equal? Notice, there's not two answers. Grace?
1.
X equals 1. And then what should we do with that x equals 1, Grace?
Sub that into one of the equations.
Which one would you like to do? Equation 2 or equation 1?
Probably 2.
It's probably easier in 2, right? So x equals 1 into 2. So what are we going to get? Y is equal to negative 4 times 1 plus 4. No pressure. Easy math. It's my love life. Kidding. I'm married. Flora?
0.
0. So this case, in this straight line and this parabola, the point of intersection is 1, 0. There's only one solution. And just to show you what we're talking about before I answer Audrey's question, again, I apologize, I'm just sketching these parabolas. That's the parabola. That's equation 1. And the straight line should look something like this at 1, 0, sorry. Something like this. Oh, yeah. And that's this one. So some of you are slowly connecting before I answer Audrey's question. Technically, you could use Desmos, an online resource, to kind of confirm it. We don't like the graphical solution. That's why we're trying to use algebraic solution. Audrey, really quickly.
So when it's like 4x equals x squared plus 2x plus 1, I don't get like where the 4x went. Like how do you figure out?
I subtracted 4x. I'm moving it to the other side. I subtracted 4x to both sides.
Oh, okay.
Right?
Thank you.
Yeah. And if you're taking physics, and yet Mr. Milton tells us that you guys don't know stuff. Enough of it. This concept, notice it touches right here.
Yeah.
It touches right there. This is known as tangent. Tangent, where it touches, a straight line touches an object only at one point. Whereas, unfortunately, I erased the circle one. The circle one is called secant. It's really like an average between 2 points. A lot of you might already know this because maybe Mr. O mentioned it, I don't know. But that is the solution. So far you've seen a circle being cut by a straight line, known as a cross twice. You're seeing this one touches only once. I think some of you are slowly kind of connecting to our examples here to help us out. Ellen, really quickly?
How did you know that the line went like that? Could it go any other direction?
From grade 9, you've learned that this is like y equals mx plus v. So this is the y-intercept at 4. So I call it, that's probably 4. And the slope of this line is a falling line. It falls 4 units and runs 1. So it falls 4 units and runs 1. And that's why, I know the graph's a little too small, maybe the photocopy didn't do it, but that's why I recommend, even though it's done in the PowerPoints, and you can check it yourself on Desmos or GeoGebra, whichever graphic program you like. Question B, really quickly. I don't need to belabor the point. We're almost done for the lesson. For this portion, and I'll let you guys work away. But so question B, same equation, right? The quadratic y minus 4 equals negative x plus 1 squared. But Saba, notice rearranging it is good, right? So you can definitely do it again, but you don't have to do it again. And the equation line is y equals 3x plus 13. I'm just going to speed this one up if that's okay. And again, you should try it yourself though, just to experience it yourself. These are kind of silly. This one's a little rare because I think a lot of you can kind of predict. Anyone volunteer want to predict what the answer is going to be, even though I haven't finished it? Anyone take a guess? You have 3 choices, right? 0 intersections, 1 intersection, or 2 intersections. Anyone want to take a guess? Flora?
Negative 110.
Sorry?
Negative 110.
Is incorrect. That's not what I'm asking. So this is the straight line, and this is the parabola. So let's take a guess. Any volunteer? Is there going to be 0 intersections, 1 intersections, or 2 intersections? Anyone just want to take a guess? Judging how I'm teaching. Grace?
0.
It's probably going to be no intersections. And that's why I'm just trying to give you a hypothesis, right? So there's a parabola that's already kind of drawn for you. That is actually the graph, the same graph. So just to do exactly kind of what your classmates said, I think it was, I can't remember. Someone said sub 2 into 1. All right, so this is now our new equation 2. Equation 2 into 1. So watch carefully what we're going to get. 3x plus 13 is equal to negative x plus 1 squared. 4. Notice this is the stuff what Saba did nicely. It's very, very similar, right? So I'm trying to get you used to it. It's not always going to be like this, but in this example, this is what you're going to do. Just to speed it up, when you move things around, like you subtract 13 both sides, you expand this, blah, blah, blah. We're going to get to this. Okay, so I am speeding it up. I encourage you strongly, check my math to see that you can do it. It is on the PowerPoint if you want to follow along. But I do encourage you, once we get to this, x squared plus 5x plus 10, this is probably not factorable. There's no product that can give us 10 or a sum that gives us 5. Can't do cross max, whatever. So let's do quadratic formula. So we're going to get negative 5 plus or minus 25 minus 40 all over 2. And already, a lot of you know, under the discriminant, this is negative. So just to give you an idea, for solving for x, the roots are complex. And again, one more time, the whole point of what I'm trying to tie in to this whole massive quadratic unit, although we can have complex roots, on a real number line, x-axis, and a real number line, y-axis, they're never going to intersect. So this one has, there are no intersections. And just to sketch you again what's happening, and I'll try to do my best to draw the same parabola. For this question, and we'll use a different color like blue. For this straight line, y equals 3x plus 13. It looks something like this. It's never going to cross that parabola. Does everyone agree? These lines mean it's going to go on forever, but this is going to go all the way. So I'm trying to show you visually the graphical solution. Hopefully you can see it on the screen. And that's why you can't, because you can't solve this. You can't plug this in. You will get complex intersections, which we want real solutions. The whole big idea before I answer Flora's question, before we get to example 3 and example 4, because that's what I'm going to end up with for this portion. Again, for linear and quadratic systems, what you're trying to awaken now, unlike the grade 10 stuff that I showed you, you can now have 0, 1, or 2 intersection points. Laura, do you have a question?
Yeah, so if let's say the parabola is not given, how can we determine like they're not gonna intersect?
So that's why I need to show you an uncomfortable situation
Oh,
where when you solve for, like, if you get like a complex x value,
and without solving the opposites, can we see
you
it?
can't finish it. This is actually what I'm trying to show you for this question. It's never going to intersect.
Yeah.
It's never going to intersect. Grace.
When we draw the line on our graphs, do we have to draw it like exactly, or can we just like?
You can just be sketching. This,
Okay.
the graphical is just the proof of what I'm trying to show you. I'm actually trying to teach you the algebra on what you're supposed to be doing, the math component that I'm to confirm it. Any other questions? It's okay. Example 3, if you take a quick look at it, let's say finding the points of intersection of a line and a reciprocal function. We're going to just skip this, but if you want to try yourself, in fact, I encourage you, go to Desmos, try to plug in that equation, maybe if you have time today. Plug in that equation of that straight line, the x plus 3y minus 12 equals 0, and see where those line and this function actually intersect. But I'll give you the answer orally. The answer for question 3, and it is on the PowerPoint, the point of there's only one point of intersection. It is 6, 2. So 6, 2. Example 3, though, I'm going to ignore it because it's not a quadratic. So let's just skip that one, okay? We're going to go to the last question. And this is example 4, and this is like a real problem. And hopefully you can absorb this. And again, don't get me wrong, I know it's long. So I'm going to try to give you all the answers to this relatively quickly. A skydiver jumped from an airplane and fell freely for several seconds below, releasing her parachute. Her height, h in meters above the ground at any time, is given by that equation. H equals negative 4.9 t squared plus 5,000 before she released her parachute. And at h equals negative 4t plus 4,000 after she released the parachute. So there's two kind of things that are happening. A lot of you already know the first equation, that's probably the parabola. And the second equation, that's probably the straight line. How do I know? Again, because the degree of the t is 2 for the quadratic and 1 for the straight line. So let's answer this question. And example 4 will be the last one. We'll take a break. And hopefully this will help you with your assignments. It's okay to ask questions. Example 4a. How long after jumping did she release her parachute? And so just to show you what I'm talking about. I'm basically subbing in the equation for h, for h. So subbing 1 into 2. This is actually, and if you were paying attention, this is actually what's called comparison. When you have isolated the variables already, I mean, I am subbing 1 into 2, but comparing two equations, that's what we can do. Anyone still lost out on how I wrote this? This one was given the parabola, and that's a straight line, and then we sub them in, then we can start solving. Hopefully follow along. We get negative 4.9 t squared plus, I might have a typo, plus 4t. Oops. That did this fast. Plus 1,000 equals 0. To speed things up for our class, don't panic. I don't think, a lot of you are noticing this is a decimal. So the chances are you can't really factor. We don't normally factor with decimals, right? So a lot of you understand. Let's use the quadratic formula, right? Quadratic formula, just to speed it up. T is equal to 4 plus or minus the square root of 16 minus 4 times 4.9 times negative 1,000. Not negative 1,000. I might have did a typo there. Oh, I know what I did. Sorry. Let's go back to step. Sorry. I was correct. This is correct. Plus 4t plus 1,000. Now, just to you can work with this one, but some students like having a positive a value. Sorry, I'll just do this one. Either one is fine. Everyone agree? Everyone agree that these are exactly the same. The a value is negative, and then by multiplying everything by negative 1, it just changes. So I apologize. For my solution, I'm going to use this one. Is that okay? Sorry. So that's why I was noticing a typo for some reason. So I got 4 plus or minus, this is because it's slightly easier. It's 16 minus 4 times 4.9 times negative 1,000. And it shouldn't really matter, right? Over 2 times 4.9. So again, this becomes calculator work, and I know you're just copying this out, but I do encourage you to try it yourself if there's some time later. Notice what you're going to get. You're going to get 2 solutions. Because this is a word problem, you get approximately 14.7, and t approximately is also equal to negative 13.9. And again, mathematically, this is a good answer, 14.7 and negative 13.9. But it's a word problem. Anybody from class can kind of remember? Ella?
You take the positive one?
Yeah, the negative 13 is inadmissible, or we reject it. That's what that means. Because we can't have a negative time, right? This is h is for height and t is for time. We can't have that. So mathematically makes sense. So at 14.7 seconds, right? That's the answer for question A. After how long did she release her parachute? She released it at 14.7 seconds. Question B. I think a lot of you know what the question says. How high was she above the ground at that time? So this is the time, 14.7 seconds. So I think a lot of you know h is equal to negative 4. 14.7 seconds, that's going to be multiply that, plus 4,000. I'm basically subbing this solution into the straight line when she releases her parachute, where she follows the linear pattern. And her height is going to be at, again, this is some straightforward math, is 3,941.2 meters. Again, it's approximate because we did some rounding. And again, it's a math problem. We're not too worried really about significant digits in math, although in science you would be. So just don't get mad at me. This is just like classmate was asking, as long as the procedure is correct. Let's just pause here. Does that make sense what I'm doing here? To show you what is happening though, let's just graph them both for you. And again, this is just a sketch for you. And again, it's probably better on the PowerPoint. So at 5,000, that's where she was. And she starts falling, right? But at a height of 4,000 meters, and again, this is not drawn very well. It's not drawn very well. That's almost 4,000. It's like 3,000, it's almost 4,000, right? Everybody agree? It's not quite. And that's at 14.7 seconds, right? So, had she been falling, free falling, this is her pattern that she'd get. But as she falls, then she released her parachute, and then she's going to go this path, right? So, just to trace what's happening, and this is exaggeration. At 14.7 seconds, she starts shooting out the parachute, right? So for part C, let's read that question. Part C says, if the parachute was released, when will the skydiver land on the ground? Landing on the ground for the parabola is here. Everyone agree? That's the ground. But this is height and that's time. But we're following this red pattern. So I think a lot of you know what I'm going to do. For part C, she's just going to continue this straight line. We just have to find that out. So negative 4t plus 4,000. The height is going to be 0.
Mr. Leishman, please call 505. Mr. Leishman, please call 505.
So she'll land in 1,000 seconds or 16 minutes and 40 seconds. And again, what's kind of neat is this is kind of like the point of intersection for this problem. And there is another answer, just that's at negative 13.9 seconds that, again, your classmate Ellen said, just reject. Any questions about today's mini lesson? That kind of ends everything that for the quadratic. Any questions about that? So try it yourself right now. Again, one more time. Look at the example 1, example 2, and example 4 only. You can skip example 3 if you want to. You can take a look at some of the questions. I'll be honest with you, you don't have to do so many of these because on your assignment, you have the question, right? So if you want to take a look at that now as well, but you don't have to do the assignment right now because again, it's due
on October 9th, this Friday. And you can hand it online or you can hand it to me in person. In person, of course, it'd probably be on the 7th or 8th. Does that make sense?